Welcome to the extra support video for connecting F and F prime assignment. I have unsubmitted everybody's assignments on Schoology, regardless of the grade you got, even if you got everything right. So it really means like nothing. I just did it for everybody. And if I see that you resubmit your assignment, then I will regrade it. The date that I'd like you to resubmit that assignment by is the end of the day, Friday, December 11th, as I would like to get them like regraded over this upcoming weekend. You do not need to send me an email if you redo it. This is something that a lot of students got like 6s and 7s on, so I'm assuming I'm going to have a lot of people redo it. So if you're watching this video, it just means that you'd probably like to redo the assignment, and this should help you. So again, here is the main idea for if you'd like to resubmit. So here you go. Your assignment has been unsubmitted on Schoology. Everyone's has. You may make corrections in the doc, so you don't have to actually do the corrections on like the comments, because that is difficult. Then you can resubmit your assignment, and those corrections / resubmission is due by Friday, December 11th, because I will grade it on Saturday. There's not like a hard, deadline. If you turn it in super early in the morning on Saturday, I'm just going to grade it sometime this Saturday. So make sure you have it in. Again, you do not need to send me an email if you resubmit it, because I will just take a look at the new submissions and grade any corrections. If you do not submit anything, that's totally fine. Your grade will just stay the same. The main thing that students missed on this assignment is like in number 3. So just not necessarily just an idea for number 3, but the main idea is that when your original function f is increasing, that means that your derivative is positive. And in math, we denote being positive as greater than 0, right? 0 is the great divide between the positive and negative world. Increasing, we'll talk about what that means, but basically the derivative is the slope of your tangent lines. It's your slope. So if you're going up, that means your slope, your derivative, positive. In that same token, when your original function is decreasing, that just means that the slope there is negative if you drew any tangent lines, and therefore your derivative, which represents the slope of any tangent line at whatever point, that's negative. Now, when your function is neither increasing nor is it decreasing, that almost, I don't want to say always, means a minimum or a maximum point, but a lot of times it means a minimum or a maximum point. So when your function's neither increasing nor is it decreasing, that means that the slope of your tangent line would be 0. You have a horizontal tangent there. So this is the main idea behind number 3 on the assignment. Number 3 is a more like, I don't want to say it's theoretical, but it's just kind of understanding this theory and this idea behind the relationship between f and f prime. What is graphed in number 3 is f, the original function, yet I'm asking you questions about f prime. And a lot of times students had issue writing an interval notation, which we will talk about next. Okay, let's say we have an example of a function, some parabola, and it is x squared minus 6x plus 7. Then hardly anybody missed the work to find f prime, but remember, in order to find f prime, this is the definition of a derivative. You need to find the limit as h approaches 0 of f of x plus h. So we do this whole thing. I'm not going to go through all the work. I'm just going to show you. So here's f of x plus h, right? Then minus f of x, and then all over h. Okay, magic fairy elves are working, and we find that f prime of x is 2x minus 6. If you had issues with actually finding this in your work, go back. I've done this a couple times in other videos, and this is something we've focused on. How did I get this so fast? Magic. You're going to learn how to do it fast too very soon. All right, so we have f of x and f prime. Notice that f of x is a quadratic function, and its derivative is one less exponent, right? So its derivative is a line, a linear function. That is always the case. Let's graph it and talk a little bit about intervals. To start, I only have the graph of our original quadratic function checked. So I'll hit this soon to show both of them on the same graph, which is what you're required to do on the assignment. A lot of you got this part. You actually graphed it correctly, which was really cool. Hardly anybody missed that, which is great. So we understand how to find the derivative by hand. I'm so proud of you guys for that. You did a great job with that, almost everyone. But the intervals is where we didn't really understand what we were doing. And that's kind of my bad. I made an ass of you and me and assumed that we knew how to write intervals. So let's talk about what increasing versus decreasing means. This is going along with the idea that when our original function is increasing, it means its derivative is positive. So let's think about where this original parabola is increasing. Increasing means well, first of all, if we read a graph like a sentence, left to right. So as we look left to right here, our graph is decreasing here. Our parabola literally is going down from left to right. Then once x is 3, here, we don't care about the y values. I just care about x because it's left to right, x values only. Once we hit 3, our parabola, our function begins to increase. Literally means like going up, right? So when we talk about where our function is increasing, we would say that our function f of x is increasing, and I'll just say INC, on the interval from 3 to infinity. Again, this is not a coordinate point. This is an interval. Yes, they look similar, although a coordinate point wouldn't have an infinity in it. But an interval means x values, literally left to right. So in an interval, your left number, or negative infinity, needs to be less than this value here. So it goes left to right, least to greatest number-wise. And that is where our function goes up, from when x is 3 to forever. Then if we think about where our function is decreasing, that is where it is going down. So our function is decreasing here, from when all the way to the left, from when x is negative infinity until when we hit 3. Now I have open parentheses in both cases around 3. That is because at x is 3, I don't know why these keep moving, but just glitchy. When x is 3 here, our function is neither increasing nor is it decreasing. It's in limbo. It's at the bottom. It's a minimum point. And that is where our function is neither increasing nor is it decreasing, at exactly when x is 3. And that is not an interval. It's at only one spot. So again, intervals are written in terms of x values as we look left to right. So all horizontal, you don't worry about the y. The only time you really care about the y is that that's what literally increasing and decreasing means. It means what are the y values doing. So they're decreasing here on this interval from negative infinity to 3, and then they're increasing here. F of x means y. So f of x, the y values increase on this interval and the y values decrease on this interval. The y values neither are increasing nor are they decreasing when x is 3 here. They're in limbo. They change from a decrease to an increase. Now, we need to talk about its derivative because we expect our derivative to be positive in this interval. It's where our function's increasing. If we were to draw tangent lines here, all their slopes are positive. So our derivative needs to be positive from when x is 3 and beyond, and our derivative should be negative to the left of 3. Our derivative should be 0 when x is 3. So let's see if that's the case by graphing our derivative in this same plane. All right, we have graphed our derivative now in the same plane, and we see that that's the case. This linear function here, this blue line, is our derivative, f prime. And we want to see where is it positive and where is it negative. So, and real quick here, I actually changed all these to red because that F is literally red. So again, didn't plan this video before I just decided to do it. So sorry about that. Okay, so this is just the same stuff I had. It was just blue before, but since we're talking about the red function, the parabola, I changed these things to red. Nothing else has changed. All right, let's talk about when f of x is increasing, our derivative should be positive there. So we want to write that our derivative, f prime, is positive, meaning its values, its y values, are greater than 0 all here. What does y being greater than 0 mean? It means we're above the x-axis. If I picked any y values here, they're positive. So our f prime of x, our blue line, is greater than 0. And again, intervals are x values from 3 and beyond, not including 3, because it's 0 there when x is 3. So we write open 3 to infinity. And look at that. It's the exact same thing as here. So when f is increasing, our derivative is positive. That's the relationship. So when f of x is decreasing, we would expect our derivative to be negative there. Let's see. F of x is decreasing from negative infinity to 3. So is f prime of x, our blue line, is it less than 0 there? Are all the y values under the x-axis? Yes. Yes. So that interval when f prime of x is less than 0 is negative infinity to 3. It is under the x-axis there. Oops. Then we want to take a look. When is f of x neither increasing nor is it decreasing? At x is 3. The relationship is that our derivative, our linear function, our line, is 0 when x is 3. So this is our entire relationship. If you look and see, when your original function increases, that means your derivative is positive. When your original function decreases, that means its derivative is negative. And when f of x is neither increasing or decreasing, most often at a minimum or maximum point, that is when the derivative equals 0. And that's what I was trying to get you guys to understand. And I think a lot of us did understand that. We just didn't understand how to write intervals. So I'm going to do one more example with how to write an interval. Here's our last example, just writing intervals. I'm not going to talk about really the derivative here. But if we take a look, actually we can talk about the derivative a little bit. Let's think about when is f increasing and when is it decreasing. All right, let's talk about that. So this is our original function f. And let's talk about when it's increasing. F of x is increasing on what interval? It looks like f of x is increasing from negative infinity until when x is 1. So here's where x is 1. And that is where we go from our function going up, increasing, to going down, decreasing. So f of x decreases on the interval from 1 to positive infinity. Then we'd say that f of x is neither increasing nor decreasing, all my shorthand there, at x equals 1, because that is where we have a maximum point in this case. Now let's talk about where, I'm not even going to graph the derivative, but let's talk about where the derivative would be positive and where the derivative would be negative. The derivative would have to be positive at any point where we're increasing. So where we're increasing, our derivative would end up being positive if we were to find the derivative and graph it. Our derivative would end up being negative anytime our function is decreasing. And our derivative would equal 0 when x is 1. Number 3 on this assignment deals with this kind of more, again, I don't love the word theoretical for this, but more of this like idea where you don't actually graph the derivative, except it uses a cubic, so we have a couple more intervals to talk about. However, this is the main idea with intervals, is that they're x values. So we're looking left to right and they're x values. So I hope this extra support helped. If you still need extra support, you can always join me during my office hours. Thursdays and Fridays for this week, and the week before Christmas break, it'll just be Wednesday and Thursday, always from 3 to 3:30. Okay, I hope this helped, and if you'd like to resubmit, please do so on Schoology so I can grade it this weekend. Take care.